Hello everyone, my name is Fanelwa Ngece-Ajayi. I'm an associate professor of physical chemistry based at the University of the Western Cape at the chemistry department. Today I'll be talking to you about the role of chemistry in our lives, what chemistry is all about, but most importantly, what the chemical sciences degree at the University of the Western Cape entails, what you need to do, what marks you need to enter the course, and obviously the most important thing again would be where is this degree applied after graduation. So chemistry, if I may define it, it is the branch of sciences concerned with substances that make up matter, how the properties of those substances are studied, and also reactions pertaining to those substances, and also how these reactions can be studied as to how they are able to make new substances. So as a chemist, basically, your responsibility is to find out how are these reactions linked within life, in water, in the environment, and how obviously you can come up with new substances if that would be your speciality. But as you would know by now, that chemistry is life. Everything you do is chemistry. Everything that goes right in life or that feels good is always considered to be chemistry. I have chemistry with this person. I feel chemistry. Those are the terms that people use in our, our everyday lives. So when we say chemistry is life, what we mean is that even from breathing in air, breathing in oxygen, how does oxygen make your body feel good? What do the lungs do? What chemical processes or mechanical processes lungs use to process oxygen? To making tea, the amount of sugar you put into the amount of coffee and the ratio of milk that you put in your cup. That is chemistry, because whatever feels good to you may be different to somebody else. So that's also a chemical process. Making tea, simple tea. Cooking, again, when you form steam, when you cook rice or meat, whatever the case may be, that's also a chemical process. So you can see that it's not just in the lab, but it's in everything that we do in our daily lives. That's where chemistry is. But where else? Water treatment, again. Chemical processes are used to study ways in which water can be treated. They are also used in order to create substances that are used to clean water. The makeup of plastics, the composition, which is what we know as plastic, that is a chemical. There's a chemical process attached to how those plastics are made. To fertilizers used to grow plants or to grow grass, whatever the case may be. But what fertilizer is also a chemical. It merges with the soil and it allows plants and trees to grow. Medicine, antibiotics, Panado, for instance, a painkiller, how Panado interacts with your body. It gets into the bloodstream, it takes away pain. That is also a chemical process. So that you can see now that everywhere you look, there is a form of chemical process either in life, to heal us, in the environment, in the air, wherever the case may be. Birth control medication. One is to understand how do these medications or these pills help females to control birth. To batteries in your charger, in your laptop, in your phone. Those are also made from chemical processes, how the batteries are made, the components are put into those batteries. Those are certain types of chemicals that are there. So now, most probably, you're convinced that chemistry is actually everywhere. Whatever you do is chemistry. So at the University of the Western Cape, the chemical sciences degree, without bragging, it is one of the best degrees at the university. You would come into the university to do the course, but it's also attached to practicals, which I'll talk about later. When you do apply for this course, obviously, you need to attain a 4 in mathematics and you need a code 4 in physical sciences. But that is the minimum. That is the minimum amount or the minimum code that you require in order to get to a course. The higher the marks you get, the better for you, the better chance of getting placement into the course. So code 4 means that you would have attained a percentage in mathematics and physical sciences, which is between 50 and 59%. But for a better chance and a better placement, because the program is highly competitive, you then need to get much higher marks in these two subjects. You also need maybe life sciences, which would help you. or information technology, but that would then depend on the kind of electives that you would take. Now, electives are subjects that you take at first year that complement the course that you need. But for chemical sciences, at the forefront is mathematics and physical science. So those are the two things. Let me repeat myself, it is a highly competitive, but it would guarantee you a place at our department. But then again, when you do get to the University of the Western Cape, what is this chemical sciences all about? So within chemistry, there are various forms of departments, or let me say various forms of subheadings under chemistry. One is analytical chemistry. Now, analytical chemistry deals with the use of equipment in order to understand the compositions and structures of matter. In our case, we are dealing with the understanding of chemicals, and we use equipment in order for us to be able to understand all those compositions and structures. Now, it is analytical because analytical concepts are used in order to understand these processes. These are examples of machines that are used during analysis in analytical chemistry. So remember, this is one of the many streams of chemistry. At first year, when you do come, you are going to do analytical chemistry, and you will be subjected to some of this equipment in order to understand the chemicals that you will be using at first year level. Then we have organic chemistry. Organic chemistry deals with all the compounds that contain carbon, how they form new structures, how they form new reactions, how they form new bonds, and how new bonds are formed or broken. That would then mean that you have now new compounds being formed through breakages of bonds or through the formation of new bonds, which leads then to the formation of formulas, different types of formulas. So this is organic chemistry, everything that has to do with carbon structures. You would know carbon by now at grade 11 or grade 12. So all the structures or all the chemicals that have carbon in them would be studied through this subsection of chemistry. Now, this is an example of structures that contain carbon: ethane, butane, ethene, ethine, cyclohexane. These are all the structures. So you will see that there are different types of structures which speak to the same chemical. Ethane, there's a molecular structure or molecular formula. There's also the condensed structural formula. There's expanded structural formula, 3D structural formula. So these are all the different ways in which organic molecules, that is what we call them, organic molecules, when you study them, using organic chemistry. These are all the different types of methods in which these chemical models can be illustrated. Then again, another example that I like to use is the one in front of you, a typical application of organic chemistry using liquid extraction. Here in the first flask, we have two substances dissolved in water. So here you then want to, sort of separate these two liquids. So what then happens? So in the middle one, you add a immiscible. In the second flask, a second immiscible insoluble solvent is placed and the solution is shaken. In the third flask, we see how there is separation of two liquids within this mixture. Now, in organic chemistry, this would be a typical example of an experiment that one would do, somebody like you at undergraduate level, in terms of separating one or two or sometimes three different organic molecules. So you see that on the third flask, you're waiting for the partitioning to happen and drain off the bottom part of the flask. So this is a typical example of how organic chemistry can be applied in a laboratory setting. Physical chemistry, which is my specialty, I like it very much. So this is a branch of chemistry that is concerned with all the applications and techniques and theories of physics. And all those theories and techniques are now applied into chemical systems. So for example, temperature change is an important aspect, but there's an emphasis on temperature change in some areas in physics. But as chemists, we are also interested in chemical changes. But the question would be, from a physical chemist's point of view like myself, that what equations that deal with chemical change can I use as a chemist to understand my work. So there's so many physics concepts that you know by now. So now imagine taking those physics concepts and applying them to understand the various chemical systems or reactions. That is what physical chemistry is about. Here's an example of understanding the difference between a physical change and a chemical change. So the difference here is with a physical change, you look at how a substance would change physically. If you melt a block of ice, you would actually see how it reduces in size as soon as you take it out of the refrigerator. When you chop wood, if you have a log of wood, when you chop it, you are changing the size of which it was at the beginning to become much smaller. But when you take the same log and you burn it, that will be a chemical change because you're changing now the internal structure, the external structure of that log of wood, and you're breaking it down. Now, physical chemistry has to do with what are the things that influence those chemical changes. What are the equations? What are the physical sciences equations that one can study to understand the burning of the wood? What can we look at? What equation defines the melting of ice? So those are examples. Another example is mixing vinegar and baking powder. So what equations from physics can we apply in understanding that chemical change? Because when you mix vinegar and baking powder, you get a new product. So what equations can we apply, borrowed from physics, that can understand what the process is all about? Then inorganic chemistry is another stream of chemistry. Why mention these streams of chemistry? Because these are the common ones that you will meet when you come in as a first year student. So inorganic is often compared to organic chemistry. The difference is that with inorganic chemistry, it deals with salts and it deals with crystals. And when we talk about salts, we also talk about ionic compounds. What are they? How do they look like? What are their reactions? When we talk about crystals, we talk about metals, metal sentence. What metals are people working with? What metals would you as a chemist work with? How they interact with other metals? What new compounds are formed? So they're often, compared with organics, which looks at fats and sugars, which are all compounds with carbon or hydrocarbons within them. So inorganic, another beautiful stream of chemistry that you would be interested in. Now you're probably asking yourself that what would happen to practical sessions as a chemical sciences student should, unfortunately, coronavirus proceeds and we don't return back to campus, or we do return back to campus, or we do not have contact time. If we do come back to campus, which I'm confident we will, practicals as an undergraduate student at our department takes place once a week. Once you have had contact with your lecturers throughout the week. So once a week, you have an opportunity to once more interact with your lecturer or other lecturers in the department, as well as demonstrators who are postgraduate students and third-year students who will help you and guide you through the process of the practicals. Now, the importance of practicals as a chemistry student is that it allows you to view what your lecturer has spoken about in class. Everything about chemistry is application. You need to smell the chemicals. You need to touch them if need be. You need to observe what your lecturer has spoken about in class. So these aspects can only be observed when you are in a laboratory setting, in a safe environment, dressed safely, of course, in your lab coat, with eye protection, with your safety glasses. But this is the fundamental part of your course, because as a chemist, you cannot graduate without having a practical experience, because when you do get into the workforce or you start your own business, you need to understand how the various processes take place. Once, of course, you would have understood by then which of the chemistry streams you are really interested in. But this is important because you need to attend them once a week to prepare thoroughly beforehand before you come for these practicals. But again, should we not come back? You're probably asking yourself then, what would happen if we do not come back to campus, or we do online teaching, what would happen? Or we do come back, but we are forced to do our practicals online. This is achievable. You can do your practicals online through simulations, and you can do your chemistry practicals through augmented reality. So these are very, very important aspects, because they talk to what is everything is talking about now, which is the fourth industrial revolution. So how then, as chemists, do we apply the use of technology in our work? It's through simulations. So when I talk about simulations, let me just show you a diagram. When we talk about simulations, for instance, the first diagram here, simulations are mimicking the makeup of a reaction through a software on a computer. So if you see the person sitting here, this is a whole chemical setup that has been made and has been put through a software for a student to work with. So that is one example. So what that means is that you would then have the ability to mix one or two chemicals and see the product. Not only that, through your computer software, you would also be able to view the different types of glassware that you need to conduct the experiments. Again, through the software, you would also be able to know and learn what do then I need for me to enter the lab, or how should I dress. So the difference is that with this, you can do the experiments before coming to the laboratory. And when you do come to the laboratory, you're actually more confident because you would have done the simulation isolated from the lab, and that gives confidence because you would have done it independently. But coming into the lab, in lab, would then mean that you need to then mix the actual chemicals in order to get the product. But where we are now is the future of doing things, the use of technology in everything we do. And as chemists, we've adopted this very well in using softwares that provide simulation. So at UWC, we have a package called Learning Science, which has really been a blessing to all chemistry students because it does the work effectively without the students being in the lab. And then when they do go to the lab, they are then able to set up the experiment such as this. They would know which equipment goes where. They would know what to analyze within their samples. Then there's augmented reality. So augmented reality deals with the projection of molecules or chemical structures onto our normal space. You can see the example that we have here of two people sitting, but they can see that there is a molecule sitting right at the top of the table. That is augmented reality. Once again, you will see that there's a periodic table as well on this screen, right at the bottom here. You'll see that the periodic table is projected onto the environment of the room. Now that is augmented reality. The beauty about augmented reality is that it's interactive, just like the simulations, because you can use an application on your phone, or you can use an application on your computer that would allow you to project whatever object or chemical structure or object that you would like, and you would then be able to interact with it in space in 3 dimensions. Why is that exciting? That is exciting because you would then be able to see all the small functional groups of your structure. You would then see where are the likely possible areas where bonds can be formed or bonds can be broken. So this is very lovely because it allows you as a chemist or as a chemistry student to have a better understanding of your work. So again, chemical sciences, career opportunities is what everyone is always concerned about. I mean, there's quality control, there's process control, there's research and development. The list is endless. Chemists fit in almost all arenas or all careers. One would go into a research scientist where you come up with projects to solve any medical or any environmental problems that people come up with. Then there's forensic scientists, which is also a very exciting area to look into as a scientist. Specialities there which chemists bring are understanding what chemistry has happened either in blood spatters or in any biological samples found at crime scenes. Then you also have the medical and healthcare sector as well, that chemists come in. In pharmacology, as mentioned before, you need chemists to come up with the core ingredients of medicines for those applications. Quality control, food scientists, chemists also come there as well. They come in to check the quality of food, the quality of substances in which food are made up of. So manufacturing as well. Food technology, how the food is packaged. Chemists also come there. Engineering, energy, substances that make solar panels. Chemists are also needed there. So the list is endless. Even sometimes in law, some chemists have transitioned and become lawyers as well, where they've used their chemistry in order to defend their clients who had cases that had chemistry problems relating to it. So there's so many things as a chemist. But again, the other thing that is really not mentioned or taught in school is the ability to use your chemistry that you've learned in business as well. So how can then you develop an idea while at school and also translate that into business? It's one thing to think about when you graduate or before graduation, but some chemists have also transitioned into business, but they've used their knowledge of chemistry in coming up with new and very, very, very novel products that they've put into the market to be commercialized. So thank you so much for joining us today. And I hope to see you at our department in 2021. But I hope that you keep well and you prepare well for the upcoming examinations. And good luck to you all.